Hi everyone, we are going to see about Boolean function and logic gates. First we are going to see about binary logics and its gates, then Boolean algebra. Binary logic gates, binary variable takes one of the two values, because binary value means 0 and 1. If we take the variable capital A, it assumes the value A 0 or 1. Logical operator operates on binary values and binary variables. Logical operators, we are going to see about OR operations, AND operations, and NOT operations we are going to see. Basic logical operators are the logical functions. Thus are logical operators are AND, OR, NOT operators. Logic gates, implementation of logical function, next we are going to see. Then Boolean algebra, it is a useful mathematical system for specifying and transforming the logical functions. We study the Boolean algebra as a foundations for designing and analyzing of digital system. Notation example, here taken variable y, the input variable a and b. If we can write y equal to a dot b, it means that y is equal to the a and b. If we write z equal to x plus y, then it will be equal to z equal to x or with y, logical operation or. If we write the x variable equal to a bar, then x is equal to not a. Here general mathematical expression, if we are adding 1 plus 1 which is equal to 2. But in the case of a logical operation, if we are taking 1 plus 1 which is equal to 1, higher value of 1, then higher value of 1 is equal to higher value. An operator definition. Operations are defined on the values of binary values 0 and 1 for each operator. Here we are taking a AND operation. AND operation means multiplication symbol. So we are also using the symbol of dot here. For both the binary variable of two inputs, we can take the two combinations 0 0 0 1 1 0 1 1 combination. By multiplication, 0 is multiplied with anything is 0. So 0 multiplication with 0 is 0, 0 multiplication with 1 is 0, 1 multiplication with 0 is 0, then 1 multiplication with 1 is 1. This is an AND operation. Next one is an OR operation. OR logical gate which is equal to an addition operation. 0 plus 0 is 0, 0 1 is 1, 1 plus 0 is 1, then 1 1 is 1, it is equal to OR operation. Then NOT operation. NOT operation means complement, reverse case, inverse case. If it is a 0, 0 bar is 1, if it is a 1, 1 bar is 0. These are the logical operators and or NOT. Then truth tables. We can take the two variable for truth table listing out. For an AND gate, we can take the two variable x and y input variable. If it is an x and y input means y is an output, z equal to x dot y. If it is a 0 0 0 0 1 0 1 0 0 1 1 1, because it's an equal to multiplication operation. Next is OR gate. For an OR gate, which is equal to an addition operation. For an input variable x and y, output variable is z. For an OR variable is a 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 1 is 1. Then for an NOT operation, NOT is an inverse gate. So is it equal to x bar means 0 is 1, 1 is 0. Here logical function implementation. For inputs logical 1, we can take the switch circuit for an AND operation, OR operation and NOT operation. The switch is connected parallelly for an OR gate. For OR gate means switch is connected parallelly. If the voltage is connected here, a switch is connected parallelly, two switches connected parallelly. Here is a resistor. Either one of the switches closed means we can get the output. So it is an OR operation. Either it can be closed, or if it not the case, if it closed means we will get the voltage at the output. If both the switches are closed also, output is 1. If both the switches are on means output is 0. For logical 1, switch is closed. For logical 0, switch is open. Then next for an AND gate, both the switches are connected serially. This is also for logical 1, light is on, logical 0, light is off. If it is connected serially, means if both the switches are closed, means output is 1. Any one of the switches open means the output is default 0. So if both the switches closed means output is 1. Here applying 5 volt here. Here it is 1. If it is the 1 means the output is 1 here. For a NOT gate, single switch is closed normally. Single switch. Logical 1 is switch open, logical 0 is switch closed. Next, and it is a symbol of a logical gate symbol. So behavior, the AND gate symbol is represented like this. The OR gate symbol is represented like this. The NOT gate symbol is represented like this. And the waveform behavior in the time message flow. If it is 0 0 means output is 0, 1 1 means output is 1. It is in Boolean algebra. The Boolean algebra for an addition operation, taken variable x plus 0 means which is equal to x plus 1 means 1. Here we get to have much attention. If you are adding any variable with 1 means output is 1. Normally the mathematical operation, if you are adding any value with 1 means we are taking that variable. But in the logical operation, if you are adding any variable with the 1 means the result is 1. Then if you are adding same variable 2 times means the result is a single variable. Then if you are adding the variable with the corresponding inverted value means the result is 1. A plus A bar is 1. Then if we are taking a double complemented value, this value is x. Then here it is an, if we are multiplying x variable with the 1 means the result is x. If we are multiplying x variable with the 0 means the result is 0. If we are multiplying x double time means the result is single variable. If we are multiplying x with the complement value means result is 0. Next 4 laws we can study through the Boolean algebra. Commutative law. Commutative law. In the commutative law means we can interchange the variables position means the result value is the same. Here for example, here x plus y equal to y plus x. We are interchanging the position of the variable but the result is same. Here xy equal to yx. Both are commutative law. Then associative law. Associative law means if we are taking the 3 variable x plus y plus z, then if we are interchanging the addition part x plus y plus z, we are adding the x plus y variable and then the result value will be added z which is equal to the value of x which will be added the resultant value of y plus z. The same case for multiplication. If you are multiplying x1 y, the resultant value is multiplied by z means which is equal to the x value which is multiplied by the resultant of y into z. It is an associative law. Next is an distributive law. Distributive law means if we are multiplying x variable with the y plus z, then x which will be equal to the x is individually multiplied with y, then x individually multiplied with z, both are added together which will be the equivalent result of the distributive law. Here x plus yz can be rewritten as x plus y into x plus z. Next one is the De Morgan's theorem. Next one is the De Morgan's theorem. This will be see in the next video.